What if I told you the largest source of recycled steel on Earth doesn't come from deep underground mines? It comes from here, scrapyards, where old vehicles meet their end and begin again. The auto recycling industry is a surprising, massive system that quietly powers our cities, bridges, and even the next generation of cars. Every year, over 12 million vehicles in the US alone are dismantled, crushed, and reborn, turning scrapyards into some of the most efficient steel mines ever created. So, what happens when your car dies? And how much value is still hidden in that rusting shell of metal? You buy a car for $48,000. 10 years later, after thousands of miles and countless memories, it's ready for retirement. But even then, it holds value, a lot of it. Welcome to a $60 billion global industry where old cars don't die, they evolve. From metal to memory foam, up to 75% of a car's total weight can be recycled. Steel, aluminum, glass, plastics, every part can be reborn. That old vehicle might one day become a skyscraper, a refrigerator, or even someone else's car. And this isn't just good for business, it's essential for the planet. Each recycling cycle saves up to 74% of the energy needed to mine and process virgin metal. It's the ultimate industrial comeback story. It all begins at the intake area of a vehicle recycling facility. Whether it's a rusted-out sedan or a wrecked SUV, every vehicle is logged into a digital tracking system. Technicians record the VIN number, engine type, year, condition, everything. Photos are taken, a tracking code is added, the car is now part of the system. Next comes inspection. Technicians look for reusable parts, engines, transmissions, electronics, seats, doors. Good components are salvaged and sold into the booming used auto parts market. The rest, sent straight to dismantling. And here's something you might not know. Over 95% of end-of-life vehicles in the US go through this system. That makes cars the most recycled consumer product on the planet. Before a single bolt is removed, safety comes first. Step 1, remove the battery. Conventional lead-acid batteries are removed immediately. They're almost perfectly recyclable. Over 98% of their lead, plastic, and acid is reused. If it's a hybrid or electric car with lithium-ion packs, those are handled with extreme care and sent to specialized facilities. Next, all fluids are drained. Gasoline, motor oil, brake fluid, coolant, even refrigerant from the AC system. A steel probe pierces the tank, and a high-pressure vacuum extracts every drop. It's not just about safety, it's about value. These recovered fluids are filtered and often reused to power the facility's own machines. What's left is safely stored for later use. Then the dismantling begins. The wheels come off first. Tires are shredded into rubber granules for roads and playgrounds, or used as industrial fuel. The metal rims, sent straight to smelters. Next, the windows. Automotive glass is laminated for safety, but it can still be recycled. Special machines slice out the windshields and windows, recovering both the glass and the PVB layer inside. The PVB, reused in soundproofing materials and coatings. Then come the doors. They're more complex than they seem, multiple materials packed into a single component. The metal frames go to remelting, while motors, wiring, and switches are stripped for copper, plastic, and magnets. Inside, the dashboard, seats, and carpets are removed and sorted. Copper is recovered from wiring. Plastics and fabrics are shredded and reused. Finally, the engine and transmission, the heaviest and most valuable assemblies, are taken out. Some are rebuilt and resold. Others are broken down for steel, aluminum, and even precious metals from catalytic converters. At this point, the car is just a hollow metal frame. But there's one more step before it's crushed: rough processing. Giant hydraulic shears, machines with metal jaws and crushing power, tear off anything left. Plastic bumpers, tangled exhausts, stubborn radiators. This step removes materials that can't be smelted or might damage the crusher. Now, clean and stripped, the frame is ready for compaction. A massive hydraulic press crushes the vehicle with forces between 150 and 200 tons. A structure more than 4 meters long is compacted into a dense cube of metal, just a tenth of its original volume. There are different machines for this. A car baler turns cars into dense metal bales, great for storage and transport. A flattener compresses cars into thin sheets, ideal for smaller yards, and a shear baler slices them into smaller sections for direct feeding into shredders or smelters. Different methods, one goal: to turn an entire car into manageable chunks of metal, ready for recycling. Now it's time for the shredder, the mechanical heart of the operation. Inside, massive rotating shafts with interlocking teeth rip through the compressed frames. Within seconds, an entire car is reduced to uniform metal fragments. Modern industrial shredders can process up to 150 tons per hour, hundreds of cars each day. After shredding, a sophisticated sorting line takes over. Powerful magnets extract carbon steel. Eddy currents separate aluminum and copper. Plastic, rubber, and fabric are discarded. From a single car, this system extracts clean, sorted metals, ready for melting. And it does all of this in under an hour. Next, the steel bales head to the electric arc furnace. Here, graphite electrodes unleash powerful currents, creating arcs of electricity hotter than lava. Temperatures rise above 1,600 degrees Celsius, melting the steel into a glowing river of metal. Lime and flux are added to draw out impurities, which rise to the surface as slag. Oxygen burns away unwanted elements. Sensors and spectrometers monitor everything, ensuring the steel meets precise composition standards. What emerges is a purified pool of molten steel, ready to be reborn. That liquid steel is immediately sent into the continuous casting line. It flows into water-cooled molds, solidifying into long billets. These billets become the raw form of modern steel products. Some are square, destined for construction. Others are flat, destined to be rolled into steel sheets or automotive parts. Each billet is scanned, logged, and prepared for its next transformation. Now comes hot rolling. The billets pass through a mill of giant rollers, flattening and stretching them into sheets and coils. High-speed cameras and lasers track every detail to ensure precision. It's like sculpting metal muscle, powerful, controlled, exact. Freshly rolled steel is then cooled in a highly controlled environment. Water sprays rapidly reduce surface temperature, followed by massive fans to cool the rest evenly. This preserves the internal structure of the steel. Once cooled, every coil undergoes inspection. Ultrasound checks for internal flaws. Cameras examine every surface. Mechanical testers verify strength. Only perfect steel passes. What began as an old, worn-out car is now clean, high-quality steel, and ready for construction, manufacturing, and automotive production. That car you once drove could soon become a building frame, a bridge girder, or a part of someone else's new car. From dismantling and draining, to crushing and shredding, to melting and reforming, auto recycling is one of the most efficient and sustainable systems in modern industry. It saves energy, it reduces environmental impact, and it powers a $60 billion economy. So the next time you drive your car, remember, its journey doesn't end at the junkyard, it just begins again. What surprised you most about this process? Let us know in the comments. And if you found this story as fascinating as we did, don't forget to like, subscribe, and hit the bell. Here on Factor In, we bring you the untold stories behind the industries that keep our world moving. Thanks for watching.